Hello my friends, welcome to Incidental Electronic Channel. This is Uncle Misha. Always wanted to have a little amplifier, which I don't have to bring my integrated amplifier, which weighs a ton, to show someone a cassette player, CD player, anything else, and output on a speaker. So I decided to get this little teeny tiny kit of the amplifier. So this is, let me pull the PCB and I show you, because it says here, this is stereo audio amplifier based on two TDA 2030 chips, version 1.2 from Canaduino. Yes, this is the, I think, Canadian company. They probably run this sort of set of PCBs, and now together we're gonna make this amplifier works. So obviously we have whole bunch of parts right here, and for this purpose I'm gonna use this little nice tray just to empty everything in here, well, except the schematic. And here is very simplistic schematic here that we have. Alright, so what do we have here? So we have 12 to 24 volt DC. This is very liberal power selections. So there is no positive and negative rail, only positive right here. So you don't have to use any special power supply. Then we have audio input. We have obviously filtering right here. And then we have, I don't know why they say 220 nanofarads and like capacitor with 2 and 1. What? It's not polarized. I don't understand. Anyways, so this is essentially input volume, knobby. Then we have, this is power filtering, 2200 microfarad capacitors clearly is a power filtering capacitors. Alright, then we have a filter for treble and bass. So all these like RC networks is mostly for that. And here is another network for just for that. Then we have, I think, oh, my neighbors is doing something. Wow. All right, so more filtering right here. So here two of our TDA 2030 chips. All right, this is the output, some diodes there, and bypass capacitors right here, and that's pretty much it. I'm just curious. It's another filter here. Right, I'm just curious. I don't see really, it's so tiny font. I'm kind of just try to understand what the value is. Okay, and yeah, speaker output. So it's fairly simplistic. A majority of components, like if for example wouldn't be no regulation of bass and treble, it's be even more simplistic. So let's do it. Let's assemble it and see. Maybe because I'm not sure what kind of capacitors being used right here. So we may just try to use different capacitors because I'm not 100% sure. For example, well, here is the capacitor. It's like I cannot even read the name of the capacitors. It's like Hongs. Like I never seen these kind of capacitors, and they're super light. They feel like super light. So I'm just curious to give it a test. Like before we start, let me test this capacitor. Well, it's not too bad actually. It's relatively, it's like actually doesn't even read it. ESR 2200 microfarads true. All right. So let's keep it, because I do have some good capacitors I can replace it with. But for first run, I'm gonna do what we have, and then we'll fiddle with it. All right. So this is our board. So to aid in our work, I'm gonna use this helper for reason because this thing is very handy when you need to rotate board up and down, right? So when you're working on board, that's gonna be super handy. So you keep it like this, rotate, solder, insert, solder, very nice, very easy. So as usual, we're gonna start with the smaller bits and pieces. For example, with resistors, like okay, or with capacitors. Let me move it right in here and we speak. And also it's very good to go from one side to another of the board. So here's our board and here's our parts. Yeah, so obviously there is nothing saying here what's the value of these resistors, but you're using the color coding, we can figure this out. So before continue, I decided to pull all big parts out of this little box because they're just interfering. Especially those heat sinks is clearly not supposed to be here. Right, the knobbies too, gonna move them out. Very nice and cute. The connectors as well. The chips are fine. Okay, so now we have a whole bunch of small components left. So all resistors are already out, so what you're gonna do, I'm gonna take a pen and mark them all. I don't want to go and look up and check up every time I'm gonna touch a resistor, because don't remember on top of my heart or on top of my head the whole color coded values. So we're gonna write the values right in here on this piece of paper. All right, so before I actually continue putting everything together, I decided first of all mark all resistors, and I noticed that these two, 1 kilo ohm and 33 kilo ohms, are not even in schematic. So I don't know where they came from and why. So all capacitors are here. Double check if everything is here. Seems to be all other resistors are marked and present. 4 diodes, 2 ICs, and here's a whole bunch of little ceramic capacitors. This one doesn't have proper markings, but I assume they are where are those? 4.7 nanofarad. I can measure them. All right. This one are 2 extra. I think I don't really see 100 nanofarads more than 2. So right here only 2. I don't know where else. There are a lot of these 220 nanofarads like everywhere. So like a lot of them, and 22 nanofarads as well. So here are they. So seems like everything is present and I can just go and continue soldering. Okay, so my first goal would be to properly select and install all resistors where they're supposed to be and solder them. I'm gonna just kind of spread those like a little bit to prevent these resistors kind of escaping on me. Alright, so I think it's a good time right now to take the soldering iron out and solder all these jars here. Did we solder everything? Looks like. Now it's time to chop it off. Okay, here's our resistors are all set. So next step will be probably diodes because they are installed as resistors. So diodes is very important to obviously observe the polarity, but for our convenience, the polarity is already marked here. So we have to just match it with that sign on the diode. And they are all four identical 1N4007 diodes. Diodes are here. So next step would be a ceramic capacitors. Ta-da! Alright, let's just solder all this capacitor kingdom. All capacitor kingdom. Well, it's not all. So there is also electrolytic capacitor kingdom, which is still pending. Okay, let's clean up. So these potentiometers, they all 50 kilo ohm, so it doesn't really matter which goes what. The only what's important, that's the straight leads, because it looks like they are quite bashed here. So this is the thing, before you solder these guys, it's better to pre-install them, like not screw, not solder. And then solder it, because that will make sure that the IC is soldered in the right height in relation to the heatsink. Always observe the polarity. Longer goes into positive, shorter is negative, longer positive, shorter negative. If you not sure, better to double check. Anyways, so now we have to supply some power to it and see if it's not gonna blow up. Alright guys, so I did double check everything, and seems like there is no shorts. I measured some of the points where I was suspicious with ohmmeter just to make sure there is no shorts, and seems like everything is fine. I double checked connections and double checked some of the elements and I soldered when it was questionable, and still everything seems to be alright. So let's power this thing up. So I have prepared 12 volt 200 milliampere current limiting power source, power supply, and see what's gonna happen. Okay, alright, so it suddenly jumped to like 160 or something, but now it's at 33 milliamp. So right now this device runs at 12 volt and consumes 33 milliamp, just doing nothing. So next step would be apply some signal and see what's going on. And I need to find the speakers. Let me also solve this problem. Alright, I even put some knobs on it. So now is the time to test it up. So let's power it up. So I'm gonna apply 12 volt, alright, but first of all we have a source. So source are gonna be cell phone with some 3.5 millimeter connector, but the most interesting what I prepared are these, hey, come here, are these car pull-offs. These are speakers which I acquired, I don't know where I got them from. These are Oxford branded. I think this is a Chrysler sign right here, and it says made in USA. I think this is full range speakers, and they are from the car door. I think so. So yeah, for the experiment, I think they'll be perfect. I already soldered some leads, and here I'm connecting them. Okay, and obviously I don't have such a fancy connector. I just solder straight to the speaker. Okay, let's power this guy up. Back to our 30 milliamp. Oh, I see, I hear some clicking while I was pushing this in. That's kind of positive. Alright. Okay. So let's do some YouTube non-licensed music. Ha! And it just works! Okay. Oh yeah. Looks like I'm touching something and it's treble, this is bass, works. Cool! I didn't do much at all, I just put it all together. Alright guys, sorry, it was loud. I will edit this loudness during the video editing. Wow, the thing works. I'm not sure what's the technical characteristic, because I started soldering it together before even telling you the technical characteristics of this little amplifier. So here they are. Oh wow, I think this is actually quite a nice product. I'm pretty happy that for about 1 hour I spent of my time actually created myself a little simple amplifier which can be powered from pretty much anything, or even like 3 18650 battery, so that's how you call it. Even if you pull out some kind of old car speakers, you can make yourself real nice portable amplifier. So now I have to just MacGyver how do I put it all together, and maybe I'm gonna have another project with you guys. So obviously we have to shield all this, and but for now this is all looking pretty good. I'm not sure if I can or want to improve anything here. One of the improvements will probably replace all these crappy cones into some proper capacitors, and that's pretty much it. Maybe everything is that is in audio part will be replaced with proper polymer capacitors. Whatever is around power supply or filtering doesn't really matter. Yeah, in terms of maybe this around power supply, maybe it does matter to put some proper cap here, but the lab power supply is pretty good power output anyway, so it doesn't really even need those. So yeah, oh guys, I'm very happy. So this is dual TDA 2030 amplifier from Canaduino, and thank you guys for watching. Don't forget to subscribe, like, comment, and I'll be happy to hear from you. Stay safe and ciao.